So I would like to say a big welcome to everybody who's joining us online, everybody who also has joined us here in the room, and also, of course, to our colleagues from Pix4D who've come from Lausanne, I think, to be with us today. So I'm delighted to introduce two CERN alumni. We have Andrea Dotti and also Emma Matson. And then we also have Alicia Soraya Gomez. We have Isabella Danibale and also Marc-Aurel Brotier. So without more ado, I'll leave the floor to you and then we can follow up with the Q&A session afterwards. Thank you very much.
Thank you very much, Rachel. It's a pleasure to be here. I'm Andrea. Here you see the colleagues with me from Pix4D. We will speak in this order, so here in the strict order of appearance. And we are going to talk a moment about Pix4D and what we do at Pix4D. I hope you will find this talk interesting. As Rachel said, I'm CERN alumni. I've been here as a fellow in the Atlas experiment first, and then in the Gen 4. And yeah, so let's start going. Let's start. So let's start with a very ancient map. Okay, this is a 15 reproduction based on the Ptolemy geography book. Right? So this is one of the first how the ancient were understanding the world around them, and the known world at the time looked like that. So since the very early birth of humanity, humans have always tried to understand the world around them and understand how to describe the world to make sense of it. And of course, the maps represent really a lot of the mindset of the people at the time. So for example, at the time, the most important part were lakes, rivers, and seas where civilization could grow. So it's normal that the map here, very ancient, especially at the border of the known world, for let's say for Western European civilization, and the most prominent things that we see are actually rivers. Now, if we do a jump several centuries later, you probably recognize this. Okay, I can see. Okay, yes. Okay, sure. So this is the world. Now it's complete. America was discovered, and it's basically a Mercator. Here we see another map that is really representing what was most important at the people of the time, right? We are in the discovery area, big discoveries of the new worlds, merchants. And what is important here is that the routes where the sails should go are straight line, represent a straight line. And this has a consequence, as we probably know, that areas are lose the correct proportion. So the north, the more closer you get to the poles, and the more disproportionately larger this area here. But again, what was important at the time was to have a correct representation of the merchants' routes. So this is why this was preferred. And if we do a jump in 1933, we can see when we bring at the extreme this. This is a Harry's Beck map of the London Underground. This is very familiar to us in every big city, but was the first time that the underground map was represented for the tube was represented like that. It was a revolution. And this is very important because it's nothing to do with the geography of the city above, right? Distances makes no sense. Directions make no sense. Everything is represented as a straight line. But this is an abstract concept that we know very well, is a connectivity graph that helps us navigate the city. And if we go to one place to another, the most important thing and the most easy way to understand the space around us is like this. Last case is, this is Jon Snow, another Jon Snow, not the one from the movies and the books, the cholera map of London. So London at the mid 19th century was flageled by cholera. It was not clear from where it was coming. The theory was that it was coming from air. Actually, we know it's not, it's from water. And Jon Snow, that is a physician, had a brilliant idea, was the first one to do it. He put on a map of the neighborhood, his neighborhood in London, a dot where family had a death.
And it just showed that we're all clustering around the pump, this one here, that actually then discovered was the source of the infection, because there was a school or something like that that was discharging the wastewater directly in the pump. And he invented, if in a certain sense, geographical data science, so GIS. So what is very important for us? Pix4D, in a certain sense, is why I talked about this map. I talked about this map because Pix4D enters in this very long tradition that is to make sense of the world around us with acquiring data and transforming them into maps with modern technology. And thanks to modern technology, we don't only have maps, but we also have 3D representation of the world. And we will see mainly 3D representations. So Pix4D is a Swiss company, but we have 6 offices around the world. Developments are being done in Europe, in Madrid, Lausanne, Berlin, and Bucharest. And then we have also commercial offices in the US and Tokyo. We have 70,000 users that have collectively mapped at the peak around 12 million hectares per year. And we have a large network of resellers. So what we are doing is photogrammetry. And to explain what photogrammetry is, I switch to Isabella, Isa, that will tell you a little bit more about the science behind that. I think this environment is very interesting.
So hi, everybody. My name is Isabella, as Andrea said. Thank you so much. So I have a, sorry, just a minute. Voila. So as Andrea already introduced, Pix4D is the market leader in photogrammetry software and mobile 3D scanning. What it means is that our customers try to represent the real world through our softwares. They do that by taking photos with planes, drones, phones. You'll see later a little bit more in detail. And they use our software, different products, depending on what they want to do, to build maps or 3D models. Before I actually go ahead with the definition of photogrammetry and what it actually is, does anybody here know photogrammetry already? Do you have a bit of, okay, so a couple. So just bear with me because it's going to be basic concepts for others to get on board with what we do. So photogrammetry is a science or a combination of science and engineering because it touches different fields. And it's about obtaining reliable information out of the real world, out of objects. And this is done through recording, measuring, and interpreting this photographic imagery. In photogrammetry in particular, I use, let's see if this works yet. I use some fancy words here just to say that in photogrammetry, we might use images that come from sensors that can capture electromagnetic radiation. So for example, how surfaces reflect the light, or in this case, radiation. And this is so that we can get more than just visual information out of images. We can get something that is measurable and that customers can use to measure the models that they create. Another important point is that the photos that we used are typically geocalized, so they can be placed somewhere in the world according to the coordinate system that is chosen as a reference system. And when I said that it involves multiple disciplines, it's because it's a mix of geometry, optics, and image processing. So this is a project that we actually created here last Tuesday together with Andrea here. And we thought it was more interested in showing something random. And I'm going to use it to talk about what we actually do as a what our software and algorithms do. So the general idea, the problem we had is that our customers want to go from a real object, so 3D, then they get images, it's 2D, and then they want to get back to 3D dimension, but with an object that is represented digitally. How do we do that? So what I actually did, I don't know if people can see me correctly, from home, but we took this and we attached a device to it. I think Mark Ryle later is gonna talk a bit more about what this is, but this is basically to get, for example, the GPS information on where I am. And I started to walk around the magnet that is here in the campus outside Restaurant 1. And I started to, so the magnet, you should imagine it more or less like in the middle here. I was walking around it. And while I was doing it, I started one of our softwares that automatically takes photos. And as you can see, the same point, for example, I took A as example here. We could have taken any other point in the object. The same point is represented in different images, just from different angles and from different positions. So we collect all these, the software collects all these images, and then it has a logic to recognize each physical point, and it maps it to the pixel or pixels that represent. So we end up with matches, and we end up with this representation in pixels. Then the next step is that we have to triangulate those matches back into something that makes sense in the 3D world, in the virtual space. So we have again, we have another step of the algorithm that takes care of that and leverages the GPS position of each image. And then out of the matches that we found before and their position, we project them into the 3D world. And we create this cloud of points. It's called point cloud in photogrammetry, but it's actually a cloud of points, a mix of points. At this stage, it's not super precise yet, so we have other steps to improve and make it as pretty as you saw it before in the final model. Now, another thing we can do, and customers use it a lot, is the accuracy. So the fact that we can, I'm not sure if this is big enough, but here it should be. We can, through our interfaces, this is Pix4D Cloud. Once again, Marco is going to describe it later. It's one of our products. Customers can use it from their browsers. And we can take quite precise measurements of each part of the object. I took a random one here as example, but it can be anything. And this can be used, for example, in engineering. It's one of our use cases. Or even here when they have to map physical infrastructure and they have to take measurements instead of going manually to measure every single piece of their object. They just use our software for that. And then we have other use cases like surveying, agriculture, and public safety and incident reconstruction. Now, I think the next one is going to be, so Marco is going to go in details in the product. And then later on, Alicia is going to dive into the technical side of the latest challenges, both for photogrammetry and for Pix4D, because we do photogrammetry, which is integrating with AI, but it is for later.
Hi, everyone. Hi, everyone. So I'm going to present how at Pix4D then we use this advanced science and to put it in the hands, I would say, of everyone, of a comment, how we can make it more affordable to different industries. So we built an ecosystem of different products so that people can have more easy access to this technology. So we start at the level of data capture to make it very easy with either drone with Pix4D capture, which will help you like map the area you want to scan, or with Pix4D catch, which I'm going to present after, to do with your phone and with the device for the precision. And then we have a list, we have a cloud product and the desktop one where you can do the processing on your own computer with more settings configuration, which I'm going to present. So here for the data acquisition, usually our customer have a drone with different type of camera. They can have a camera with infrared, for example, or standard one with different definitions. And then now we have a mobile phone and using this device, which is a RTK real-time kinematic device to get a really precise position at the centimeter level or to get really where was the phone taking the photo to have the correct angle, everything. And that help us provide really the centimeter accuracy on the output at the end. So the workflow, the standard workflow would be you go around, you capture the pipe that Isabella and Andrea took the other day. And with the app, for example, we improve the feedback to the users so they know how well they capture the data to ensure the quality of the data set they took is good enough for us to process and to produce a good output for them. And then they can even see directly the result on the app, and better, they will look at it later on their computer to do whatever annotation, export, change. And with, for example, the app on the site, you have the AR field comparison. So as you see here, there was a scan done of a trench, and with the opacity layer, you can navigate at the same place 2 months later when it was filled and finished, and you can see how it was built just under you. So that it helps to really navigate there and to precisely find if you need to change something, there was a problem, you just need to open the hole at one location. Then there's different application. Our customer is using the tool today. It's for underground utility mapping because they need, with the new legislation, to produce the digital twin of the pipes, of the materials they used, so they can scan the trench with the pipes, and we can produce the output for them with, but they can export in a CAD file to get a report with what they built. Another use case is for construction, so they can put an IFC file, so the CAD file from the architects, on top of the scan, and you can verify, like here on a construction site, each week or each day, if everything that has been done during the day is correctly aligned with what was planned, so that speed up in case to rebuild, to move something, a wall, and not wait until next month that someone come on site to do the measurements. We have people using it for crash reconstruction. So they go after a crash, the police will come with the app, scan the scene so they can clean the scene quickly, because that's kind of their first goal as well, to make the traffic go again. And then they still have all the data, they can measure, they can really do all their post, in a sense, processing of the scene afterwards on the computer without losing anything, compared to having standard 2D photos where they're gonna have more problems to get a sense of the distance of the scene. Another one is, of course, indoor capture, where you can do a floor mapping of your apartment, of a room, and get the measurements even out of it. And last, the standard application like surveying, you can scan, usually it's more with a drone than a phone, but maybe because it's in the city, it's harder to fly a drone. So you would take your phone, you can go around the building, around the neighborhood, and do the scanning and get you map afterwards with all the buildings for the city. So then when you get this data, you can choose either to use the cloud or the desktop app to do the processing. On the cloud, so they just upload the photos and we do the processing for them. And then they can use the UI to present, to share either the data set with colleagues and integrate whatever annotations, measurements in it, so that the output, when you collaborate on it, you get all the information that you need on the scene. In terms of size of what we have with the customer today, we have more than 5 petabytes of data. We do a lot of CPU processing per month. And we present in 5 regions so that our customer can use the correct, in a sense, legal region for them to store the data, and we do all the processing for them in that region. So they, in a sense, compliant with their country regulation. If you want to see some projects, we have a demo page with a QR code or with a link. where we provide the different use cases with the phone, with drones, the crash scene, the different type of use cases that you can look into and play with interface. Then the other tool would be on your own computer with Pix4D Matic to process, in a sense, bigger data sets because we have some limitation currently on the cloud. So, and to have a faster processing depending on your computer, and of course have way more configuration, customization you can do for the processing. So it's really depending on what would be your end goal for the output. Where you can have a GCP checkpoints, so many options to do the processing and to play with the results and to export the result as well at the end, of course. So you can continue your journey of your data in another software. Then we did another tool, Pix4D survey. The goal was to be able to provide an easy interface for a specific industry. So you don't have a general tool with everything inside, and you need to understand how to use it for your own goals. So we simplify some use cases with different tools. So here, this one is really about extracting the 3D data more easily, more automatically from the model. So you can extract roads, you can extract the volumes, the surface, and you have an easy export in 2D CAD files. So you can import it into another CAD or GIS software for your needs. And then a third one I'm presenting, it's Pix4D Fields. This one for the agricultural industry, because they're using different type of camera, they have really a different need. So usually they fly with infrared camera to capture different images, and they can use it afterwards for the weed detection, which then gonna be uploaded to either a spray drone or to the tracker, so that the spraying only happens at the precise location where it's needed, to limit the amount of product and to optimize, in a sense, as well the spraying. And now I'm gonna let Alicia present some projects.
Thanks. Thanks for being here. I am Alicia Soria, and I'm currently working in the algorithmic team along with Andrea Dotti. And today I just wanted to explain a few of the projects that we've been working on for the last year here in Pix4D. So first of all, I just explain a bit what is Pix4D Matic from Marco's presentation. Then in the second place, I will introduce two of the projects that we've been tackling that include semantic segmentation. And then finally, I will just show some results that we managed to obtain using Gaussian splatting in our 3D models. So just quickly, what is Pix4D Matic? So Pix4D Matic is our desktop solution in which a user can input a set of geolocalized cameras, images, that they're going to be calibrated, and we're going to obtain a 3D model or a 3D point cloud, among some other like outputs such as a DSM or an orthomosaic. But in this case, we're going to focus especially in the set of cameras, animated cameras, and in the 3D view, because there is where we developed our algorithms using instance segmentation. So the first project is mass propagation. As probably you all know, currently a user can create one mask by detecting an object simply in one image by just clicking the image, and then automatically they obtain one mask. But our projects sometimes include thousands of images, and we can imagine that creating thousands of masks can become like a very tedious and long process, and especially very prone to errors. So what we're doing here is to develop this feature that will allow the user to simply click in one image and produce one mask, and automatically obtain all of the masks in all of the set of images that are looking at a particular object. So how do we do this? We need two inputs. The first of them is the calibration information of the scene in order to calculate which is the next image. This is the image with the closest viewpoint to the one that the user clicked. So then we have that next image. And then the second input is the embeddings of the images, which are obtained thanks to a segmentation model that could be a visual transformer or some other segmentation model. In this case, the embeddings of the images, they encode in a high dimensional vector some information about the image, such as the contextual information and the semantics of the pixels or groups of pixels. So in this case, if we combine the calibration of the project and the embeddings of the images, we are able to propagate the input, the mask that the user inputted to the next mask, and so on and so forth, and then we can actually mask the whole project. Then the second project that I just wanted to briefly explain, it's about the 3D scene. So in lots of cases, the user really wants to clean up the point cloud or detect objects directly in the 3D part of our project in order to either make annotations or create automatic measurements. So what we have developed is just a feature or a tool that allows the user to just click on one dense point cloud, and automatically the other points from the point cloud that belong to that object will be selected, in this case in pink. Actually, this involves some kind of projection into the images and then some uplifting back into the dense point cloud, but this is hidden to the user, so the workflow is very intuitive and almost real time. And then finally, I just wanted to mention Gaussian splatting, which is, let's say, our baby in the algorithmic team. We can obtain really precise results and very realistic rendering. But so what is Gaussian splatting? So Gaussian splatting is this kind of novel deep learning technique in which we just scatter a set of 2D Gaussians or 2D ellipses for vector imagination into our 3D scene. And then through a process of iteration and training with the input images, we can actually minimize the loss between the renders of the 2D Gaussians and the input images until we can optimize the position of the Gaussians, their size, their orientation, the color, and the transparency. And I just wanted to make like a very special point in the fact that the color of this Gaussian splatting is very particular because it's actually view dependent, as we can see on the top of the project. So we are able to model reflections, which is actually very novel because we couldn't do it before with our 3D point clouds or our meshes. So this is actually very important for rendering. And then just wanted to finish with some examples because not only we can render the Gaussian splats, but also we can render the depth information of our project as well as our normals. And this is very important because it can allow us to continue like with other projects such as surface detection, for example.
Okay, I'm not going to say too much. I'm here in case you have any questions about the recruitment process. We have 3 positions open at the moment related to what you could be interested in, and it's Andrea and Marco Rell that's the hiring managers for this. So yeah, I don't know if you have any questions, then I'm here. That's all.
Okay, thank you. This concludes a brief presentation of Pix4D. Hope it was interesting enough for you. We tried to keep it more on the, let's say, basic science part, even if we had to time constrain to reduce it really at the bare minimum. But of course, if there are questions or comments, curiosities, we are here now, or also take it offline if you prefer. And as Emma was saying, we have now openings, also non-technical. Let me add on the here we just put here the 3 technical one, but maybe some colleagues of yours who are more interested in sales opening or things like this. So if the openings are in Madrid or in Lausanne.
Wonderful. I think, yeah, we could give a big round of applause. That was super interesting. Thank you very much to all 5 of you. So we have people who are online. I see that Michele Baroni has raised his hand and is going to break the ice. So Michele, please, if you'd like to come on screen and then ask your question.
Congratulations to the presenter for the information about their company. My question is concerned if there is any restriction in the export license for some country. Thank you.
restrictions for the export of the products of the
Yeah.
assets that are being created
Yes, yes.
based on no, there are no restrictions. So with a Pix4D license, either desktop or cloud, it's possible to export the results in formats that are compatible with other softwares. We sell basically everywhere around the world. I think we have 135 resellers, so we have a very large presence. So we typically are able to cover all the cases. So if for whatever reason, privacy, legal restriction, whatever, for example, cloud cannot be used, you can always use Matic, the desktop solution that has also the characteristic that even the most advanced models, like the one based on machine learning that Alicia was saying, will always run locally. So in this case, it's one of the points was exactly to give the full control of the on the data property to the users.
Thank you, Michele. Thank you very much. So we have a question in the chat. So one is very practical. I'm afraid I forgot my glasses, so I have to do this with the magnifying glass. So Paul was asking, said that the presentation was very interesting, and will we be able to make the slides available? Now, we do record these events. We check with the presenters if it's possible to publish what they've presented. So I think we should be able to make them available. So thank you, Paul, for that question. Moving on, we also have a question from, I think it's Maria, have I got that right? Here we go. Yes, Maria. Would you like to come on camera, Maria, to ask your question?
Why not? Hi, everyone. So thank you for the talk. So I have a few questions. The first is, so you showed that photogrammetry has been around for a long time, but today we have more available technologies, and I guess the industry is becoming more competitive. So what would you say is the biggest challenge Pix4D is currently facing, and how do you see the company positioned compared to the others in the industry? And also I have actually a follow-up question, which is if you already talked about what the next 10 to 30 years might look like for the company.
I can take it. So yeah, it's pretty competitive for sure, especially because it's getting easier. We see even like projects, open source project doing photogrammetry, and they're getting more and more better and better in a sense. So that's as well one of the reasons of Gaussian splatting we worked on last year and was able to release earlier this year to still be ahead, I would say, of the pack and have something that give more values. Because even initially, if we can see like, okay, it's nicer, but because the reconstruction is nicer, it's easier to measure and you can capture more, for example, more detailed scene, for example, like a cabinet, electric cabinet with all the labels, you would be able to get this output and be able to read the labels on them. So it's being there to see where we can push the boundaries with photogrammetry, as well as work to work with machine learning to represent more information in the scene. So yeah, it's hard. And then on as well with the drone phones industry, so we see that the drones is kind of in a sense stable because now there's more and more legislations. You need to get a pilot license pretty much to fly a drone. It's restricted, everything. So it's not going to grow crazy. But that's why we moved to the phone to provide as well an easy solution to capture data with a really good quality so that we can reach out to many more industries, people, to present them what they can do with photogrammetry. So today, I would say our focus is to get there with the phone, to reach out to those peoples and show them how they can use this technical science into their work to get the result way quicker than they would have used for like surveying, or in a new way for like those pipes and those things.
Just to add something on top of what he already shared, which of course I second, it's also that Pix4D is very well known in the industry and it has a very good reputation in the photogrammetry industry because of the quality. Like we get lots of feedback on the quality and the accuracy of the projects with our products, which I think for us it's still an advantage. And of course we need to keep innovating. So what Marco said, like we brought up the Gaussian splatting and new things. And also I think not only in terms of feature, but another kind of innovation is integrating our products. So now we can integrate catch and cloud and try to propose solutions that are easier to use for our customers, because we need to keep in mind that our customers, I mean, some of them are very technical and very knowledgeable. Some others don't have such a deep technical knowledge on the field, and they need to easily understand how to use it. And we need to try to make their lives easier. So I think that's also how Pix4D stands out in our field.
For the future, so 10-30 years is really long in this, highly technological, but I think the sensor fusion part and using multiple type of data we did not have time to discuss this, but we are already today supporting LiDARs, scans or laser scans from the phone, because some phone have actually a LiDAR. So this is something very unique of Pix4D. Another thing that I imagine in the future is that the price of LiDARs will go down, and this allow to solve some specific problems. So I really think that this part on the sensors, more sensors and more data sources, will be very important in the next years. And then, of course, what Alicia is working on, so the integration of machine learning. So we hope that the dream at a certain point is that you have a project and the most important objects are automatically found in the scene, measured, thanks to the high precision that we have, and so that you build a CAD description of the world.
So I've got to switch your mic on, sorry.
Okay, so you mentioned, I think, even twice about limitation of clouds in favor of this desktop app. So what kind of limitation of cloud you were thinking? And second question, if it's not secret, what kind of cloud you are using? Is it some public one or private?
The limitation on the cloud is with the number of images, and so we have an upper limit of 10,000, yeah, 10,000 images, which is already quite big. But just to keep data sets limited, and for us as well to ensure that the time to process, and because you need to wait at the end, maybe it's an error out at the end, the more photos you have. So today, I would say it's better to do on the desktop if you have really a big one, and otherwise if it's standard 300, 1,000, 2,000, then it works well. And then we using AWS. We don't have our own data center or whatever. They put it on AWS.
Thank you. So that answers part of Mario's question about generic cloud provider. So AWS, you said, yeah. Okay, we'll come to your other questions in a moment, Mario, but please.
Yes, thanks for the presentation. It's really amazing what you do. Well, I have a lot of questions, but maybe my main question maybe is for Alicia. If you have more experience on this now with the rise of NERF models and Gaussian splatting, do you think that these kind of models are going to completely substitute the traditional photogrammetry in the future?
We already did some preliminary experiments with NERF, and in the end they were rejected. So that's the first part. And then I don't think they're gonna totally replace the photogrammetry, because actually the beginning of Gaussian splatting is based on the photogrammetry transparent cloud. Mm-hmm. So actually we need that to begin to improve the models afterwards. So in my personal opinion, no. Then we'll see what happens.
Right.
Hi, Giovanni from CERN IT. Thanks a lot for the very nice presentation. I was wondering two things. The first one is 5 petabytes a lot of data in your field? What would be the average size of a project, for instance? And the follow-up would be, are you happy with AWS, or are you, if you can disclose this, of course, or are you maybe even planning or have planned of having your own data center or something that is size friendly with what you do? Thanks.
So I would say the average project would be about 300 photos. Then it depends on the camera type, because you have 40 megapixel camera, you have 5 megapixel camera. So, but it's more in the gigabytes, not more for the size. So yeah, it's a big amount of data. You don't just move it around or you do changes on the development side. It's like, no, it's kind of pretty static, and we need to handle it. And then on AWS, yes, I would say I'm personally happy with it. To say it's working well. It's really self-service. You almost need no support compared to what I know from my friends working with the other ones, which I hear more complaints of things. But yeah, and no plan to build a data center today, because one other thing as well you need to take into account is kind of seasonal, and even seasonal during the week. So it's like really Monday, Friday, and the weekend are pretty quiet. And then for the winter time, December, January, that's really the lowest month. And we have then 2 peaks in June and 1 in September with the highest usage. So then we can really benefit more from the cloud, and we will really need to do some work to see where we can get the value, because it's going to be then a more static, even it can be elastic, but amount of compute power that we need to have in different regions as well. So it's
that's interesting. Thanks a lot.
Yes, thank you. I would also have a question concerning the Gaussian spreading and nerve and these kind of things. We understand it's improving significantly the texture in the model, but it's not changing anything on the geometry. Or is also the geometrical model with the point cloud that is getting significantly improved compared to the photogrammetry that is initially started?
So the idea of Gaussian splatting is that you have the calibration information of your scene, and then with the dense point cloud, you like initialize a state with Gaussian splats, which will then be optimized with these positions and colors and like size and everything. And then from that Gaussian splat, you can actually create a new dense point cloud, which is much better than the first one. So yes, it removes lots of artifacts, and it's actually a bit more accurate than the beginning.
It means it's also changing the camera calibration with the parameter sets. So this is the one that is kept from the photogrammetry, and there is no improvement on that side. Okay, thank you.
The Gaussians do not change the calibration of cameras. You know, the point is with Gaussian splat, we see that we are able to create the very thin structures. So what Margareta was saying, that for a cabinet with traditional photogrammetry, it's very difficult to model the cable, so very thin structure. With Gaussian splatting, we see that starts to be possible. It's very active field. I think that you know, NERF came out a little bit before. In our experiment, did not give good results with, so we switched to Gaussian splattings, and that seems very interesting now.
Thank you. So perhaps we can move to the other parts of Mario's question. So the first thing related to data privacy, I guess, when you're using city pictures, how do you manage blurring out people's spaces if you do things like that?
Matter of fact, Alicia developed our machine learning model to do that. So first of all, the data are the property of our clients. Okay, so they need to decide if they need to respect or if they have to follow special rules. For our case, when we in cases we take up the data ourselves, we anonymize car plates and people faces. I noticed that we don't manage to anonymize the both numbers, and this was in one project was a boat parked near the area where we were, so that would have been to be blocked manually, let's say. But yes, we do that, but it's not on by default, because let's say if you run Matic, your own computer, it's up to you to decide if this has to be taken or not. If you don't share the data, probably.
And yes, so anybody who's a fan of computer games, can your technology be used in video games, for example?
They are used.
They are used. We know that also in the cinematic industry. We have a side project, let's say, called OPF, Open Photogrammetry Format. It's a way to exchange data in an open format. So we have published the specifications. And matter of fact, I know that there is someone in the entertainment industry looking at that. So video games and especially Gaussian splats are being very, very, very popular for this type of applications. We know that there are Unreal and what's the name of the big one? EA Sports or something like that. Yeah, that they are really doing something similar. So to capture an object or as a scene to be used in a video game to make a photorealistic scene.
It's Epic Games who has a reality capture and who work in the same field, and so they bought a company and so they can do it. But I remember asking my boss a long time ago about this, about transforming this, like taking real photos to do a game out of it, and it told me, it's been used, but at the time there was too much noise, so it needed a lot of cleanup to be able to produce a good scene for a video game. So it wasn't, you could do it, but not ready. Now with the Gaussian spanning and everything, I think it's really going to change the game because the output is almost clean.
We might see the new version of Grand Theft Auto then. Maybe. Okay.
Hi.
Mario, I
sorry.
hope that answers your questions. Yeah, go ahead.
Sorry, I really don't have the camera activated right now, and I have to exit Zoom to redo it. One thing about this gaming industry, I learned that the Notre Dame Cathedral in Paris was rebuilt a bit based on a video game that took place there. So just to let's see that we can use actually our images to reconstruct the world even. My other question, just to follow up on the AWS. I actually started to learn some AWS since I now have a bit more free time. And ever since this, let's say, war started with the US, I tried to look at alternatives to the American features. And I found one that is based in Switzerland, which is called Scaleway. I don't know if you learn it. Would you consider to moving it away from American industry, or you would keep it for the foreseeable future?
So for now, we don't have plans to be multi-cloud in a sense, because the thing is, you take one in Switzerland like Exoscale, then it's only in Switzerland, a bit in Europe, but you won't have a reach in Canada. You won't have a reach if you want to open one in Australia. So that's our main concern there. On the opposite side, we don't do things that are really tight to whatever AWS service to be able to get out in a sense easily. So it's feasible, but today not in any plans for now.
Okay, thank you.
If I can add on top, so I wanted to comment on your first part when you spoke about reconstructing the world. We kind of already do. Like, you remember the incident in Italy of the bridge fell, and I think somebody was involved in the reconstruction. So like like to try to rebuild it. We mapped the Matterhorn, we mapped the internal of the Egyptian pyramids. So, like it's also used somehow. I'm not too much of a marketing person, so I don't exactly know the details, but it's used also for these kind of purposes. And then getting back to the cloud topics, because I think it's the second question we have, like on, do you have plans to change or move like on-prem or in that sense, you have to also keep in mind that it's a relatively small, like we're a relatively small company. We have what, like 100 people more or less. And in the cloud team, I mean, now the cloud team where I work and Marco works, it got bigger. We are around what, 20 something people. We used to be 5 or 6 operating the cloud infrastructure. So we really need to have a real need to and a motivation to move out of AWS or like decide to go multi-cloud in order to take the step, because it's a big investment for the company and for us to learn new stuff.
So you mentioned a little bit about possibly using more LiDAR and integrating that with the visual information from the photos. And I saw something on your website about how using the information from the photos improves upon just using the LiDAR information. So I'm curious about how much using LiDAR plus photos improves on just the information that you get from photos.
Sure. Take this. Okay. So the LiDAR that we are talking about that is already compatible with our software is the LiDAR included in some top iPhones. The iPhone has a LiDAR. So this allows to get a 3D depth map of the environment. It's very limited in range, so it's 5 meters, and it's not very accurate. Of course, a professional LiDAR scanner, the one that also heavy 20 kilos, costs tens of thousands of euros, right? And you need a professional to operate it. So this is clearly relatively simple, right? So the mix of photogrammetry and LiDAR allows to go beyond the 5 meters, clearly. And the LiDAR usually helps in densifying the areas that are textureless. So a white wall is very difficult for photogrammetry because this pixel that if I mention, there is nothing, it's white. So the LiDAR allows to simplify these cases, very important for interior, for example, and also provides a beta scale constraint because the LiDAR gives us an absolute scale constraint. So we can say this wall is 3 meters away from my position here, with some accuracy, of course. So this information is complementary to the photogrammetry, and so informs the photogrammetry to have a better photogrammetry output. It's not really the other way around. So we don't take the LiDAR and improve the LiDAR through photogrammetry. We actually use the LiDAR data to improve the photogrammetry.
Do we have any other questions in the room? I have one potentially, but I don't want to prevent anyone else from asking a question. Emma, actually, this is one for you. I was wondering if you could describe the recruitment process from when someone applies, imagine someone applies. If you could just describe that, please.
Yes, sure. So after you've applied, I would say it takes, we don't have a deadline to the application. That, for example, here at CERN, you have a deadline and then you get news whether you are making it to the next step or not. We do that along the way that the position is published. But after that, there will be a first interview with the hiring manager, then with HR. Normally, there's a technical exercise or a test after that that's reviewed by people from the team, which is pretty nice because it also gives room for any questions you have regarding work environment and so on. Of course, you can already ask those questions to the hiring manager or myself. But it's also nice to understand a little bit about the atmosphere within the team, and the conversation might be a bit more casual with the people from the team. And then after that, like now, for example, both Andrea and Marco Rell is hiring in Madrid, so they are not going to be there in person every day. So then it's an additional call with head of the office in the local office that the person is applying for. And all of this is done remotely, I mean, via computer. So we don't ask, there is certain teams that sometimes, of course, ask in a final stage to come to the office, but it's also more for the applicants to get an understanding, see the office and meet the team. Marco Rell might want to.
I wanted as well to add something that, for example, in Madrid, because I would say most of the employees are in Lausanne, but in Madrid we have people for the cloud, we have already people for the R&D, so it's not like you alone there. There's already engineers, and we used to work
in a remote setup with people even in Berlin then. So it's very common for us, and it's not an issue at all.
Yeah. How long does it actually take generally, or on average? Is it fast?
The more technical positions takes longer, because if there's a technical home assignment, you know, by the time the person actually can find time to complete it and then have someone in the team to correct it, that it's quite time consuming. But on average, I would say as soon as you get the first interview, from that point until the final stage, I would say 3 weeks.
Do we have any other? Oh, yes, please go ahead.
Also, maybe to this process, is it possible to work remotely, or like part-time job is possible? How does it look?
Yeah, good question. No, so we have a hybrid work policy. So we ask all our employees to be able to come to the office at least 2 days per week. We publish our positions most of the time 100%, but we do have some flexibility of part-time. Of course, it depends on yeah, the position and whether it's 50% or 80%. Yeah.
Please go ahead. Yeah.
I got a more technical question again about photogrammetry, especially. There seemed to be quite some work done to make the software in general usable by a broad field of users. So it's user-friendly, and people that don't have much expertise can also work with it. How deep can you go into the settings, especially with the bundle adjustment, to adjust things like the camera calibration, for example, to adjust some settings there, like distortion parameters or something?
So this is a very good point, right? Let's take example of our software for farmers, that are Pix4D fields. So we don't expect any of the farmer to know anything about photogrammetry, sure. What it is, or even flying a drone is already, you need some expertise. So depending on the software, you are exposed to more or less a level of tweakability, let's say like this. Matic is the software for professionals, so surveyors, photogrammetry experts. However, we strive really put a lot of effort in trying to make our algorithms as general as possible, so that works with the minimal or no technical knowledge. So for example, when you upload to cloud, if we know that it comes from a cache because you are uploading through the phone, we can already pre-tweak the parameters so that is optimal. The calibration is optimal for a cache data set. If you import from a drone, you are asked probably not even the brand of the drone, nothing. So because we get this type of information, yeah, we just ask the type of flight. Did you fly in a row? Was a street, or was something like a squarish area that you fly? And then we can get a lot of information from the data itself. So images contain a lot of data in the EXIF, so this metadata that, for example, focal length, all the data, metadata associated with the picture. So we can use that to calculate the parameters for you. They should work. If not, your specific case, you probably need Matic and start to play with the parameters.
Okay, thanks.
We try to make it very easy.
Thank you. We have, I think if you've got time for a couple more questions, we have one from Michele, who is online. I'm not sure if Michele is able to come on the camera to ask, but he was interested in knowing more about the company turnover. Here we go. Over to you, Michele.
Yes. What about the company turnover and the total number of people employed? Thank you.
Mm-hmm. So the total is around 200. And as someone mentioned already, like that's the current employees. And the biggest, the headquarters and biggest office is in Lausanne, and we are about 100 there, and the others are scattered around the world. And then you said about the turnover.
Yes. So Pix4D is part of the
Parrot Group. Parrot is a company, public company on the stock exchange based in Paris, France. They produce hardware, drones. We are not too linked to Parrot in the sense that I think 90% of our drones are not Parrot. And so since Parrot is a publicly owned company, parrot.com/finance, there are all the numbers there. Sorry, I don't want to say now a number because I don't remember by heart. But all these numbers are public because it's a company, and there is a photogrammetry division that it's us. So I think actually pretty recently there was the 2024 numbers out.
Okay, thank you.
There's the hybrid job in Madrid, but most people are in Lausanne. Can you travel, be based in one place? How does that work? From Paul.
No, so you are placed, you are based in one of the offices. Yeah, I'm not.
Be based here and work in Madrid remotely.
No. That's also tax related. That wouldn't be legal, I think. No, so you cannot do that. No, it's up to the person that applies. But then you will be based so either in Madrid or in Lausanne, and then you also need to be able to come to the office, twice per week.
I don't know if that's part of answering the question, but like we have employees who are based physically in other offices, like an employee in our team who's based in Berlin but works with us 100%. So that is possible in that sense. So we do work remotely in that sense. It's possible. She's not employed by the Lausanne office. She's employed by the Berlin office. She lives there, pays the taxes there. She does everything there. But then she fully works with us. So this we do. As in, if you decide to move to Madrid, you want to apply there, and then working with our team, that's totally possible because we have a full remote setup pretty much every day. But yeah, then it's not like living in Switzerland and be, like that kind of weird thing. No.
Great. So I think we should give all of our Pix4D members a round of applause. Thank you so much for a very, very interesting session.